Hello. Welcome to Designing for Virtual Reality. My name is John Wiley. I'm the principal designer for Google Cardboard and virtual reality at Google. Everybody enjoying their cardboards? Hopefully most of you got some, yeah? I think we ran out, so yeah, they're pretty popular. All right, awesome. Also, I recommend, if you haven't already, after this, you can go up and check out our demo booth. The jump videos there are exceptional. Yesterday, we actually had the guy who drove the actual rover on Mars was giving the expedition on cardboard for the Mars expedition, so that was actually really exciting. Cool. Well, welcome. Thanks for coming today. Today we're going to talk a little bit about what our team has learned in the short time that we've been working on cardboard. So we released cardboard about a year ago, and the momentum has been tremendous. It was actually really surprised us, right? It went from kind of being this like 20% thing that was like, oh, that's kind of cool, to just having a lot of excitement around it, a lot of apps being built, and a lot of cardboard devices out in the world, and just a tremendous growth, and that's really exciting to see. Yeah, last year I was at I/O here to present material design, and one of the things that attracted me to cardboard and to VR. If you think about material design is its origins are in the fact that you're physically interacting with software. So, the way in which you respond to it, you're touching a physical device, and you're actually touching the software. And in that, you kind of want to have the software have some authenticity, right? It's going to be responsive, and it's going to have some physics, and motion is a first-party citizen there. You want to be true to that interaction. And the cool thing about that is that every single time that computing gets closer to the way in which we naturally sort of interact with the world, that's where the magic happens. Well, virtual reality is 10x that. It's really tapping directly into the way we perceive and see the world. And if you can get one of these demos, and again, those jump videos, you have to see them in VR. That's really where the magic is. Near things are near, far things are far, and it's really sort of tapping into that authenticity of the physical space. And we really feel like in terms of creating delightful experiences, that's really where the magic is. When computing gets closer to the way that humans naturally interact with the world, that's where great things can happen. But the inverse is also true. We raise the stakes, right, in terms of people's expectations, right? We expect reality to not drop frames. And virtual reality, if we really want it to be immersive and have a great experience, we want to make sure that we're doing the right thing and we're feeding into people's expectations about, turning around and seeing things and how that works. And so it's easy to fall into a pit where you're actually, you can create a bad experience, just as much as it is possible to create an amazing experience. And we've been thinking about that a lot since we started working on cardboard. And we're actually really excited about just the momentum across the entire industry and lots of conversation about how to design great experiences. And today we're going to share what excites us about VR, and we're also going to share what we've learned in the short time that we've been working on it. And we hope to continue this conversation beyond these walls. So with that, please welcome Erica.
Hi, my name's Erica. I'm a designer on the cardboard team, and today I'm going to be talking to you about why virtual reality. With virtual reality, you give people one of the most popular superpowers, teleportation. Imagine your third grade self learning about the Mayan civilization for the first time. But instead of looking at a textbook, you're standing at the base of Chichen Itza. This is actually imagery from the Expeditions app we announced at yesterday's keynote. Soon, teachers will actually be able to take their students on virtual tours around these ruins. Think about how much more fun school is going to be. VR also allows for more engaging journalism. Instead of reading about the earthquake in Nepal, what if you could go there and see what it's like firsthand on the ground? Think about the empathy and sense of civic duty this could inspire. And finally, how about the art world? Installations that play with space, light, and color can only be fully appreciated in person, or now in virtual reality. So, you can transport your users. You can also give them experiences that are physically impossible in the real world. How about flying? Another popular superpower. In the cardboard app called Cardboard, It has 5 A's and 1 exclamation point. Players get to dive off of buildings. And that feeling of falling continuously is an experience you can't easily get in real life. So those are a few of the many compelling use cases for VR. What are you going to make? I imagine that some of you have ideas for apps that will live entirely in VR, but I'm guessing that a large number of you have existing 2D apps that you're thinking about adapting to VR. And to those folks, my tip to you is to start small and focus on introducing VR content that for your app is a game changer. To give you a better idea of what I'm talking about, let's imagine I have a hypothetical real estate app. We have a map view that allows you to filter by location. We have individual listings with information about price and size. We even integrate with Google Maps, allowing you to easily get locations to each house. All of these tools are working really well in 2D. But one part of the app that would work much better in virtual reality is the photo gallery. Because compared to a series of photos, touring the home in VR would give you a much better sense of scale and layout. Also, think how much time you could save if you didn't have to physically visit every house that you're interested in. Ask yourself if there's any part of your app that is practically begging to be displayed in virtual reality. And if you do decide to incorporate VR into your app, here are some best practice guidelines. If you're using an icon to represent cardboard mode, we suggest using the silhouetted white icon on the left instead of the colored icon on the right. The silhouetted icon is simpler, and it's in keeping with the material style guide. If instead you're using a text button entry point, say something like view in cardboard over view in virtual reality. Using the word cardboard will remind people what they should be reaching for. And finally, many of your users won't have cardboard, at least yet. And for these users, you might consider hiding the feature entirely, or if you want to promote it, direct them to the Google Cardboard site, where they can learn what cardboard is and potentially get a cardboard of their own. This concept of introducing VR into 2D apps is still new, but there are already a number of apps that are doing it. On the left, there's Monzo, which is an app that allows you to create digital models of cars, planes, even catapults. And they added the ability to view your final creations in virtual reality. And on the right is Scene, which is an app that allows you to create and view 3D photos. And they also added a cardboard mode. And most recently, at the keynote yesterday, we announced that YouTube will support cardboard mode for 360 videos. In a year's time, over 1 million people have gotten cardboard, and that number is getting larger and larger, which means you have a growing audience for the apps that you will dream up. And as you start building these VR experiences, it's important for you to constantly test them out. I'd like to welcome Manuel, who will tell you more about building VR experiences.
Thanks, Erica. Okay, let's talk about crafting your own applications. How many of you make stuff? Okay, I just want to make sure I'm at the right conference. So, when you build applications in VR, it's very important that you try them as early as often as possible. It's kind of a temptation to just throw things together and say it looks really nice and kind of look at on your computer monitor. So something to think about is the design process here. And we're just getting started. We want to share some ideas with you, some things we explored. It's just remember to put it in cardboard, put it on your eyes as you place objects, say, oh, wow, this is too close, too far. We'll talk about it in a minute. So the goal here is to have genuine empathy for your users. Just how do they feel? How does it really feel? So although this is about prototyping and building stuff, we're building stuff for humans. Let's talk about humans. First, I'd like to talk about convergence. Convergence is the inward movement your eyes make toward each other when you're trying to keep sharpness on object you're looking at. You might say it's focus. So a little experiment, you put your finger in front of you, you look at it, it's sharp, and then you look at me, or at the stage, I'm sharp, finger, you see 2 fingers. Okay. Next one. Is this comfortable? What do you think? Okay. So I did not experience this, so I didn't get traumatized. But let's try to traumatize you. put your hand in front of you, and imagine it's a boulder, and then bring it toward your face. Keep going, keep going, keep going. At one point, for a regular human, it will be blurry no matter what. You know, basically, things that are too close to your head, you can't focus on it, you can't converge on. It's something really important to think about. And that's because your eyes are basically crossing, and you're straining your eye muscles. So there's comfort there as well, discomfort for your users, something to really think about as place stuff. A few more things about convergence/focus is objects. So people can only focus on one thing at a time, my finger or myself. Also, switching between distances, or I'm looking at this thing right here, and then I'm looking at the people in the back, and I'm looking here in the back, and if the thing is right here, if you do this repeatedly, eventually it becomes kind of uncomfortable, and different people feel it differently. Keep in mind. Additionally, people are better at judging distances between objects that are up close to them, kind of makes sense, right? My hand's here, than far away. You know, last row, second to last. Okay. So the point here as you build your applications is to always be aware of people's eyes have to converge on. It's a good way to think about it. How does it relate to you as developers? Well, it'll take you less time to, you'll make less mistakes. You'll always try it and say, is it eyes converging? Like, is people comfortable or not? So very useful for developers. So let's share some prototypes with you. This is something we tried a little bit, and just sharing with you the design process here. In this tool we prototyped, we have these outside rings, and it presents you with a zone of comfortable, neutral / zero convergence for maximum comfort. So you place objects there, and chances are when people are focusing back and forth in that area, they'll stay comfortable. So this was fun for us to try. Additionally, when objects are too close to you, it's going to zoom in at one point, there's a smaller red ring, and so this was us kind of checking things out. It's a good idea to kind of show in the design tool at one point things are too close to the person. This is just sharing some ideas. We've learned a lot from this prototype and other things we're exploring. Let's talk about scale. So in VR, scale is very important. Something key to think about as you build your experience. So there's something called IPD, interpupillary distance. And it's the distance between your pupils. And so something interesting is an accurate IPD ensures people's sense of scale matches their perception of reality in real world. So that's like regular reality. But I could be giant. My head could be massive. And my IPD could be very wide. Also, it would mean you guys, or the world, if I had a really large head, would appear really tiny. And that's really fun. So scale is fun. Have fun with it. To understand scale better, something else we prototyped a bit is, what if we drop a human body inside the design tool? And we found yeah, you know what? This is cool. Very quickly, I can tell that, wow, this is how big the person is in the world. So we learned quite a bit from that. It's fun to share with you. Something else we found is that standing and seated positions are pretty important to think about. So you stare at the person, it's like, well, we really have a person in there. It's not just for cylinders. And so people may be sitting in their living room and able to turn around. So you place stuff around them. Let's talk about field of view now. So this prototype shows two frustums. Frustums are these pyramid-looking shapes. Sorry for the math guys in the room. I got to explain it's like a pyramid. But it's a frustum. So the narrow one, the one you see right now, shows you what you can see without turning your head. So having that in there is pretty nice. So when you place an object there, as you move it into the field of view of the person, is the person going to be having to turn their head? You build UI, you have that distance in the green rings, and then you know if they have to turn their head to see everything or not. The wider one, the black one there, shows you what you can see if you turn your head slightly. It looks pretty wide. Actually, it's just turning your head comfortably. So it's nice to think about when people are unable to turn around as you build your interfaces. So just sharing with you things we're trying. Hope that's interesting to look at. Now let's talk about the Cardboard Unity SDK. How many of you have not used Unity yet, or just kind of okay at Unity, just getting started? Okay, there's a lot of you. That's good. So I went to the Cardboard website, downloaded this one file, and I'm importing it into an empty project in Unity. There's files in it, lots of files. They're all very good. I'm going to highlight 3 of them. There's a demo scene I'll talk to you about in a minute. There's a prefab called Cardboard Main. Prefabs are really awesome for developers. Allows you to just drag and drop into your scene. You know, it's done. Pretty much you have that VR rig ready to go. You get the eyes set up. There's a C# script for guys that when you guys want to build your stuff from scratch. It allows you to drag and drop to an existing camera. Maybe you have a Unity app already. Or maybe you're grabbing one that you picked up and you want to port it to VR. It allows you to turn that camera into a VR rig with just 1 click. Super useful. So if I open the demo scene, this is what I see. So a lot of you haven't used Unity much. So this scene is actually really nice first VR project as you're getting started and once you get going. It has a bunch of interactions, include this gaze input thing we have going where you see a reticle. It's also called a dot in the air, and it shows you where you're looking at. OK, so that's built in. You just copy and paste into your scenes, and you get stuff running very quickly. So if I press play in Unity, it's really nice. It runs. I can see what it would look like in Cardboard. I get the eyes going. I'm turning my head by moving the mouse while holding Alt, just a little tip. We documented that, but it's good to know. And click on these guys by clicking on the mouse, and it triggers the button on the Cardboard. But you're looking at a computer monitor now. Remember genuine empathy for your users, like how does it really feel? So wouldn't it be better to see this in VR? Something else we're working on, and there's a first version of this in the SDK we just shipped yesterday, is support for Unity Remote. The way this works is I have the phone in Cardboard, and I can move the phone around, and it's reading people's, reading the neck movement, and I can edit in Unity at the same time as it's in my eyes. I made the scene much smaller. I looked down, and now I became giant. I didn't have to wait for compiling application. Didn't have to wait for it to show up on the phone to realize, oh, this is too small, it's too big, whatever. So this just super rapid development process, very handy. I love the feature, and you will too. So for more information, go to Cardboard Developer website. And so yes, go there, download what you need. There's a lot of documentation. To summarize, I told you about a few interesting things about humans, talking about convergence, IPD, and field of view, as well as position of the person. You saw how easy it is to create your own Cardboard app. And I shared with you some of the things we're playing with there on the team, including one that is in the SDK already, which is the remote control thing. It's cool. Please welcome Alex. He's going to tell you about design principles. Thank you.
Thank you, Manuel. This is an absolutely amazing time to be a designer. And the reason it's so amazing is just how new VR design is and how much we have to learn and discover. And this isn't the definitive talk about VR design. It's still too early for that. I look forward to being able to give that talk eventually. But this talk does cover what we've learned so far, both as a team and also as an industry over the last few years as we've been diving into VR design. One of the things we found, and we saw this with the examples that Manuel was just showing with the live preview and design, is really the best way to learn about VR design is in VR itself. And this was actually a bit of a challenge for me recently. I was writing the style guidelines that are online on the web, and thinking, man, it'd be a lot easier to let people actually try this out instead of trying to write these long paragraphs. So today we have an announcement, what we're extremely excited about. We're releasing something called the Cardboard Design Lab the team's worked on. And the great thing about this is you can learn about VR design principles actually in VR, in its native habitat. So we have a bunch of different examples, things that are very foundational, things like using a reticle or keeping the user grounded, motion, things like that. We also have a lot of more advanced stuff and more immersive concepts, like guiding the user with light, spatial audio, gaze cues. So definitely go download this app and try out all of the 10 lessons that we have built into it to learn about these principles. If you're actually watching this on video, I would encourage you to pause and try out the app and then come back, and we'll talk about a lot of the principles in much more detail. So when you're designing for VR, you're really designing for the capabilities of the human as much as you're designing for the capabilities of the system. So it's really important that you understand your users and what they're capable of. So first, let's start out with a story. Imagine it's a beautiful morning, hundreds of thousands of years ago, and you wake up and you're feeling great. The sun is shining, you look outside your cave and you don't see any predators, that's awesome. And you're starving, and so it's time to start foraging for food. So you head out and you find some berries, these red berries, and you've never seen anything like this before. These look delicious. So you start eating them and you realize immediately that things have gone horribly wrong. You've got this ringing in your ears, your vision's a little bit blurry, and the worst part is everything's kind of whooshy, like you sort of move and like the world doesn't like totally track correctly. And this is a really critical moment for you because you basically have two options. You can eject the berries, or if you don't, it's unfortunately game over. And we've evolved to be very sensitive to vestibular ocular disparities. Motion sickness is actually, it's a defensive mechanism that comes through evolution. And the person that ejected the berries, they're our ancestor because they survived. So bad input can really cause bad physiological response for users. And this is something that's really important with VR design. Of course, we're familiar with phones having an inertial measurement unit. We have one as well called our cochlea. It's a sort of a series of tubes in our ear, in our vestibular system. And as we're thinking about the system as a whole, we have the phone's inertial measurement unit. We also have our own. We have the screen and our eyes. And all of this has to work in tangent, in unison, as part of a system. So it's really important that you're getting good input to the user based off of their movements and what they're seeing. Because if it doesn't, then that's going to create bad physiological responses. So this is sort of a complex way of saying, always maintain head tracking. Never drop frames. If you're starting to load a new level or a new scene in your application, it's not okay to freeze all of a sudden and let that come in. Be sure that you're monitoring performance, that you're always maintaining head tracking. It's really, really critical. If for any reason you can't, just fade to black and keep using audio in your application because people are very sensitive to these things. Another thing to talk about is motion and the concept of constant velocity. So it's kind of strange. We actually don't feel velocity. We feel acceleration and deceleration. So an example of this is like when you're in an airplane. You definitely feel the takeoff and you feel the landing. But when you're actually just flying around, it doesn't feel like you're going 500 miles per hour. You might feel some turbulence or something, but the actual velocity of the plane, you're not noticing that. Another example, we're all, of course, on the planet Earth. It's traveling very fast. If the planet were to decelerate, we would definitely feel that. But while it's traveling at high velocity, we're not feeling that at all. So this fact that we don't feel velocity is actually really important for VR design as well, because if you have someone traveling at a constant velocity, it's not going to be as disconcerting as if you're having lots of acceleration and deceleration. Because they're going to notice that difference when, if in VR they're accelerating or decelerating, then obviously in reality they're just standing there. So that can also create potentially some discomfort. And everyone's different. Everyone has sort of different tolerance levels for what they find acceptable with motion. So it's really important to try things out with users, even with constant velocity, to see how they're feeling and if it's working. Another aspect about motion is definitely keep a stable horizon line inside your application. I'm sorry. If you don't, don't drop frames either. So let's talk about vision. A really common question with vision that a lot of people talk about is, what resolution does the screen need to be for resolution not to matter? That's a really good question. There's kind of two parts of it. One is field of view. So again, everyone's different, but for a lot of people, a field of view of 210 degrees horizontally by 100 degrees vertically will cover everything. And then in terms of pixel density, if for every degree we had 60 by 60 pixels, that would be pushing the limits of our vision. That would be 20/20. Some people have better than 20/20 vision, so it's in that range of getting up to 60 pixels per degree. So something like a 12,600 screen by 6,000 with a 210 by 100 field of view would be great. That's probably actually overshooting it because we actually only have high resolution vision in our central vision with our fovea. Our peripheral vision is very blurry. This is assuming that you had like the same size pixels throughout the entire screen and you couldn't build a screen with pixels that were different sizes. So that's pretty high, and we're not there yet. And as we are on this sort of progression of increasing screen technology with phones, it seems like it's becoming harder and harder to talk about screens. We, of course, have our old favorites like VGA, but the recent acronyms are getting increasingly ridiculous. Plus, we have all of the complexity of optics with VR. So I'd like to talk about something we've been talking on the team, which is a really clear way to talk about this is just pixels per degree and the number of degrees of field of view. And just focus on those two things. So again, if we can get into 60 pixels per degree, now we're at an eye-limiting system. So reality, 60 pixels per degree, 210 degrees field of view. Let's talk about some of our devices. Nexus 5 on cardboard, not quite reality yet. 12 pixels per degree and 85 degrees field of view. Nexus 6 in cardboard does a little bit better, increases up to 13, but more notably increases the field of view with the new cardboard for up to 100 degrees. Let's talk about hearing now that we've talked about vision a bit. In a way, hearing's kind of a type of vision. So the interesting thing about hearing is it lets you sort of see the entire scene around you all at the same time. And this can help you build up a mental model of what's there before you've even seen it. So let's try out an example. So you guys all knew that there was a bell there before you even turned to look at it. Let's try it again. There's supposed to be another bell. All right. Sort of over there. So we're really good at positioning audio spatially. And what's important for this in terms of design is if you have something creating audio in a scene, you can immediately cue users into it being there. So attaching a bell to your interface is probably is a bit much. You could just have your interface hum or buzz or something a little bit. But you can definitely direct the user's attention with audio, and you can fill them in as to the world around them by using spatial audio. Let's talk a little bit about designing the environment. So one of the first mistakes we've made, and most people designing VR make, is so you drop the user into the environment, and you're not really thinking about where you're going to drop them in. So they immediately start colliding with an object. And this is very disconcerting and sort of uncomfortable. I mean, it's not literally uncomfortable because it's virtual. But you look down and you see something coming through you, and it's not good. You feel uneasy about it. So we talked a lot about physiological comfort. It's also important to talk about environmental comfort and the types of things that make people environmentally uncomfortable. So obviously heights is a big one for people. People can be scared of heights. Also small spaces, claustrophobia. Then there's the opposite of that. For me, actually, I'm more with agoraphobia, sort of large spaces, big empty rooms. Imagine working at a desk with like a single spotlight down on your desk. Like that would be very unnerving. Scale's very interesting. So when you have small objects, they have this sort of toy-like quality. They're very fun. You feel very powerful, and you're this giant. You have this tiny truck. But if you invert that, now it's very different. You feel very weak and small and very intimidated by these big objects. And it's not just things like trucks. Like you could build a user interface that was really big, and the user will feel small and diminished in front of it. Like the interface itself will make the user feel slightly uncomfortable. Other things about environmental cover, obviously people don't like to be crushed. This is an extreme example, but another example, I was in a VR simulation and it was just planets rotating around. It was beautiful. But then suddenly one of the planets was coming right at me. And part of my brain was thinking, like, get out of the way, because you can't turn that off. And for that moment, it was very uncomfortable as I had to remind myself, no, it's fine, this planet's just going to collide straight through me and everything's going to be great. So people don't like to be crushed. Also sharp objects, people aren't super fond of those. For sharp objects, in particular, people are very protective of their eyes. So imagine you have like a meditation application that has little hummingbirds in it. And one of those hummingbirds, floats up with its little hummingbird beak, like right next to your eye. The user is going to recoil away and sort of, defensively block. And that was not what you wanted, because this was a meditation application. They're supposed to be relaxed. So the important thing about environmental comfort is to be intentional. To, in testing, see the types of things that people find unnerving for various reasons, to think about it. And then involve this as part of your testing process, that you're not just doing physiological comfort, but also environmental comfort. So quick note about perspective. Almost all VR apps are first-person perspective, which makes a lot of sense. Third-person perspective is also really interesting. This is an app called Robo-Obliteration. It's really fun. You have this little spaceship that you control with your head, and it moves on the surface of an asteroid. So I think third-person perspective games for VR are also super compelling, and we're probably going to see a lot more of them be considered in the future as well. So moving on to interaction design. For a system like cardboard, basically all interaction is by moving your head gaze at objects and then clicking on them. So you're sort of casting this ray out of your head to set focus. And something we found is when people first try cardboard, they don't really move their head very much because they haven't really realized it yet. So they just hold cardboard up, and they stand very still. And that can be a little frustrating as a designer because you've created all this stuff. So something to do is if you just have something interesting off screen, just a little bit in their field of view, something to coerce them to look over at it, then they'll realize that head tracking works. And as soon as they've done even a little bit of a head movement, they get it, and they start looking around all over the place. And then, as you have users starting to look around, think about designs that actually leverage the whole canvas. Like, we don't have to design for these small 2D devices anymore. So we can create interfaces that actually surround and encompass the user and do these really creative things that haven't been possible in the past. And there's tremendous opportunity here. There's also some challenge because the camera has free will. So from the perspective of like a director or a cinematographer, where they're very focused on telling their story and controlling everything, they're probably a little bit scared of the fact that, like, wow, users can look anywhere. Like, how are we going to deal with that? So there's a couple ways of directing the user's attention. One of them is sort of a brute force approach, just rotation on scene change. So say it's a spherical video, and the user's looking in a particular spot, but the next spot that's interesting is off to the side. As you're doing that scene change and fading to black, you can actually just rotate that sphere so that wherever the user's looking, the next interesting thing is going to be in front of them. Now, don't do the rotation unless you're fading to black, because that can make the user very sick, having the world spin all of a sudden. But that's one way of sort of directing the user's attention. Another way, which is more subtle, is sort of guiding the user with light. This is a really popular one in video game design. So for people that are designing levels for video games, you'll often notice that you just sort of know the right way to go through a level. Usually find the right path and keep walking. And if you're not paying attention and you go back, you'll see that often they're really lighting your path very clearly. And that's how you just sort of intuitively know the right way to go. These very subtle cues with the lighting. So we actually have some examples about this in the Cardboard Design Lab that you can try out, where people are looking at the brightest parts. Another thing we've been exploring is gaze cues. So this is where you're tracking where the user's looking, the sort of ray that they're casting out, and then that's actually having an impact on the world around them. So we have an example where you look at constellations and they illuminate, which is sort of an interesting way to sort of make the world slightly interactive with how the user's looking at things and exploring sort of more details of the world. You can also use gaze cues as a very technical technique for as you're staging things out in your VR application. So in the lab right before, we're actually teaching spatial audio, the bell thing, although in this case it's not a bell, we have an owl. And when you look at the fire, that triggers the owl appearing. Because at this point we know that you're looking at the fire. And we know you're going to look at the fire because it's the brightest thing. So we're actually staging the owl coming out off of a gaze cue. And then the owl shows up. It's sort of a jump scare owl. It's kind of fun. So final thing about interaction design, is talking about in-world user interfaces. So the important thing to note with VR design is you can design the whole world. So you don't have to build interfaces in that world for the user to use as much as you could actually embody those interfaces in the world itself. So one developer in the industry spoke about this as, don't have a little health bar, say you're flying a spaceship. Instead, look out and actually see the damage on the wing of your spaceship. Like, that's a much more interesting and compelling way to convey that same information. Don't have all these little sort of meta indicators that are built in, because you can actually expose that interface in the world design. And across the board, as we've been doing all of this design work, something we found is that VR is a really powerful medium. And there's sort of three things that happened to me recently that convinced me of this. Just fundamentally convinced me that VR is incredibly powerful. The first one is I actually forgot I was in VR, which is maybe a little embarrassing. This was a couple weeks ago. So what it was, I was sitting in a movie theater simulation. I was at work, and I was watching trailers, and I hadn't seen the trailers yet, so they're kind of interesting. And then I was really worried because I hadn't started preparing for my I/O talk yet. And so I've got sort of multiple levels of distraction going on there with the trailers and also then worrying. And then some people right next to me started talking. And I turned, and there was no one there. And I thought, well, that's weird. It's not right. And then I realized, oh, it's because I'm in VR. And that was the first time that happened to me. So I think with enough distraction, our minds are kind of just set up to start taking the input they're getting. So you can have these moments where I mean, we have this even when you're reading a book. You kind of get lost in the story of the book. So it's very easy for people to get lost in things. But getting lost in VR is quite something. The other thing that, second thing that we found very interesting as a team is, so the industry has talked a lot about presence, this notion of kind of accepting the simulation as reality for a moment, just kind of rolling with it. Even more interesting is, pairing presence with the concept, the psychological concept of flow, where you're very your creativity is just like completely engaged, and you're, in this case with the application Tilt Brush, you're just lost, not just in VR, but you're also lost in the creative task of sculpting and painting. And this can be a really interesting experience when you just spend long periods of time creating things in VR. And then the third thing that's really struck me about VR interface design is when you're thinking back to VR experiences you had a long time ago. So because you're engaging so much of your mind, like all of your spatial memory, your sense of self is being engaged with VR, you know it's not real, and you can think back and you know it wasn't real back then. But you're still storing a lot of that experience as if it was a place, or as if it was a thing that you actually did. So thinking back to VR, you're really, for the first time, you're sort of creating users' memories. And this is amazing as a designer, because now we can really design rich experiences that people think of as places and as experiences that they've had. So this is something the team's incredibly excited about. Sort of current contributions so far, of course, go get the Cardboard Design Lab to try out a lot of the VR principles. We also have a lot of documentation online, and of course the SDK is available. And with that, we have a few minutes left to take your questions. Thank you.
Any questions? No? Microphone right there. Going once. Can you get to the microphone so we can get it on video? No pressure. Let the man through.
So you talked about how you need like 60 pixels per degree. If you change the field of view, I think you kind of mentioned this, but you changed the field of view in the latest Cardboard upgrade, and so that changed the requirements? Like, if the field of view is wider, but you have the same device, are you stretching it further?
Yeah, so the pixels per degree will actually go down if you're increasing the field of view.
And then how much of this is like lens specific? Like if I have the Gear VR Oculus headset, are those lenses different than the Cardboard lenses, and the apps need to be like designed entirely differently?
So for the Works with Cardboard program, you can, the user will scan a QR code on the device, and that communicates all of the optics information. So the developer doesn't have to worry at all about all the different optics out there.
Cool. Thank you.
Hi, thank you all for your amazing insights into VR and Cardboard. I'm a little piggybacking off of the prior question. Wanted to ask your thoughts on a user's experience in Cardboard versus something like Gear or Oculus, and perhaps something that is more high fidelity in the actual experience, and your thoughts on like designing, the differences between designing there and what you recommend for users to really get that first amazing experience that doesn't have nausea, that accounts for parallax effect and those types of things.
Yeah, I think there's kind of a spectrum of capability of devices out there, and so taking into account the capability of the device is important. For Cardboard, we tend to think of it as kind of snackable VR. It's not for like long duration experiences. Really, if you're going to, as I was saying, kind of at the very top of it, which is every capability that you add increases the constraints around making sure it's golden, right, in terms of the experience. And so you can create a richer experience with a more capable device, but you just have to be extra careful to make sure that experience is really living up to the expectations of the device. So with devices like Cardboard, at least today, given today's mobile phone technology, it doesn't have the full 6 degree of freedom tracking that you move around in a space, and so you just have to be cognizant of that and designing for the limitations of the device. I actually think that the best designs come from not working against the system, but working with the system to create a good experience. And so if you've got a high-end system that you're designing for, that's awesome. You can create amazing content. But I still think that amazing content can be created on more restrictive systems if it's playing to the strengths of that system.
Thank you.
Yeah. And I think we got time for one more.
Oh, yeah. You kind of touched on a little bit of user input, and you have basically one button to interact with the system. Are there any plans to up that ante to maybe allow users to be more specific on input, like typing or voice or things like that?
So I think part of the magic of Cardboard is the simplicity of the system. And in fact, with the version we announced yesterday, we actually made it a lot easier to assemble. So if anything, with Cardboard, we're going to keep pushing to make it more simple.
Okay.
But that said, we just showed the tilt brush example, right, and the notion of presence and flow. And that ability to actually, like with tilt brush, if you can try tilt brush, I highly recommend it because you can really get that sense of working with your hands and working in space and things like that. But as I was saying in the previous question, every single time you raise the capability, you raise the expectations for the experience. You have to be extra careful to make sure you're designing for that. So that's one of the reasons why we want to keep Cardboard really simple, because that's actually playing to the strength of a great experience for a Cardboard device.
Yeah, and I just wanted to add, like, Cardboard, you put it on very quickly on your face for a snackable experience. Your hands are also kind of busy holding it and then handing it to your friend, like, oh my gosh, this looks amazing, right? So your hands are, this is a very social experience. So your hands are used there already, so, it's something to think about as you build experiences. Their hands will be on there.
Well, on that note, is length of experience a factor that developers should, like length of time that the experience lasts?
Yeah, I think we want to, like for Cardboard, you want it to be sort of, as I said, snackable experiences. So more like YouTube content, right? Or sort of more traditional YouTube content versus like a long form experience with Cardboard. Yeah.
Okay. Thank you.
Thanks everybody for coming out.
Thank you.
Thank you.